We will now begin our discussion on the next chapter in the textbook, which is chapter number 11, which is dealing with surface areas and volumes of objects. Okay, so this first part of this lecture will cover only the surface areas of various three-dimensional objects, and then we will do some examples related to the surface areas in the next lecture. And later on we will proceed with the volumes of objects as well. Okay, so let us recall what we have studied earlier in our previous classes in class 8 and so on, where we have studied the surface area of a cube, the surface area of a cuboid, and also the surface area of a cylinder. Let us first try to understand what is the meaning of the surface area. The surface area of an object or a body is the total area on the surface of the body. For example, if you have a cube, imagine a Rubik's cube that you have in your hand. For example, imagine you're holding a Rubik's cube in your hand. Then the Rubik's cube is having 6 faces, and each face is a square. So each square face of the Rubik's cube has a certain area, and then if you add all the 6 square sides areas of the Rubik's cube, that gives us the surface area of the cube. So the surface area of a cube whose side is A is basically the sum of the areas of all its surfaces. So that's why we call it a surface area. And a Rubik's cube, or a cube in general, has 6 surfaces. The shape of each of the surface is a square, so the surface area of the cube will be the sum of the areas of the 6 surfaces that are present on its outside, on its exterior. So a cube having a side of length A, it means that the cube is having all its edges of length A. So when all the edges are of length A, each face of the cube or each surface of the cube has an area of A square, because that's the area of the square surface. So the area of a square is A into A. So we have each of the sides is having a length of A units. So this is also A, this is also A, and we'll have this also A. So each and every edge of the Rubik's cube is having a length of A units. So if we take one particular surface of the Rubik's cube, it has a length of A units for each side of the square. So the area of each square is A square. And since we have 6 surfaces on the cube, so the total area of the cube, or the surface area of the cube, is 6 times the area of each surface. So the surface area of the cube is 6 times A square. So we have seen already this formula in our earlier class, where we have studied that the surface area of the cube is 6A square. And today we have tried to understand how we have obtained the 6A square. So basically, it is the area of each square surface multiplied 6 times, multiplied by 6, because there are 6 square surfaces on the outer exterior of the cube. Okay. Similarly, if we have a cuboid surface, then what is the surface area of the cuboid? And let's say a cuboid is also a 3-dimensional figure, but unlike the cube where all the edges have the same length, in a cuboid the edges may have different lengths. For example, we have a length L. We have a length L for one of the edge, and the parallel edge will be having the same length L. Similarly, another edge has, say, a length of B units, and a third edge has a length of H units. Okay, so we call these as length, breadth, and height, for example. So whatever is L, all the sides parallel to it will have the same value L. So this will also be L, this will also be L, and this will also be L. And similarly, whatever are the edges parallel to B, they will all have the same value B. And similarly, all the edges which are parallel to H will have the same value H. and this as well. Okay, so now what is the surface area of the cuboid? Again, as usual, the surface area of any body or object is the total area on the surface. So for a cuboid, we are going to have again 6 sides, but each of the sides is going to be a rectangle. So we have one rectangle here, the front side, we can call this as the front side, which is a rectangle, and this as the back side of the cuboid, so that is also a rectangle. Then you have the top side, which is also a rectangle, and the bottom side, that is also a rectangle. And then we have the left side, which is a rectangle, and also the right side, which is also a rectangle. So basically, the surface area of the cuboid is going to be the sum of the areas of each of these rectangular surfaces on the exterior of the cuboid. So the front side, in this case, okay, let's talk about the top side and the bottom sides. Okay, the top side, which is this one over here, is having a dimension of length L, and another dimension is the breadth B. So the top side has an area of length into breadth. Okay, similarly the bottom side is also having an area of length into breadth. So we have 2 times length into breadth for the top and bottom rectangular surfaces. Similarly, for the left and the right surfaces, which is this particular surface, which is on the left side of the cuboid, and on the right side of the cuboid, the area of those rectangles will be breadth into height. Okay, so breadth into height is the area of this rectangular surface on the left and also on the right. So because we have 2 rectangles, one on the left and one on the right, it will be 2 times breadth into height. Okay, and similarly for the front and the back sides, the front side is having a length L and a height h. Okay, so the area of the front surface is length into h. Similarly, the area of the back surface is also length into h. So we have these 2 rectangles. So we have 2 times length into breadth plus 2 times breadth into height plus 2 times length into height. So you can take the 2 as a common factor outside. So we get the surface area of a cuboid of sides length L, breadth B, and height h to be given as 2 times L into B plus B into h plus L into h. Okay, so that's the surface area of a cuboid. Next, let's see what is the surface area of a cylinder. And a cylinder is shaped like the can of a Pepsi or a Coca-Cola can, right? You have seen cylindrical shapes. So a cylindrical surface, we want to calculate what is the surface area on the entire outside of it. So basically, a cylindrical surface will have 2 types of surface areas. One is called as the curved surface area, and the other is called as the total surface area. In the curved surface area, we are looking only on the curved part of the cylinder, which is the entire cylinder excluding the top base and the bottom base. Okay, so we are excluding the top base circular part and the bottom base circular part. Without those areas, whatever is the remaining part on the surface of the cylinder, that's called as the curved surface area. And then we'll have the total surface area, which will be the curved surface area plus the area of the top circle and the area of the bottom circle. So that will give us the total surface area of the cylinder. Okay, now if you notice, if you have a cylindrical shape, for example, we could roll a paper in the form of a cylinder. So when we have a cylinder formed by rolling a paper, then the height of that cylinder, let's say, is h, but the circumference of that cylinder is basically the length of the paper that is being rolled. So basically, the curved surface area is going to be the length of the paper into the height of the paper that is being rolled. So the length of the paper basically is going to be the circumference of the circle, because that straight paper has been rolled into a circular form. So the circumference of the circle is going to be 2 pi r. We know the circumference of a circle is 2 pi r. And we multiply that with the height of that cylinder. So that gives us 2 pi r into h. and that is the curved surface area of the cylinder, 2 pi r h. Now to get the total surface area, we have to add to the curved surface area the area of the top circle and the area of the base circle, which is the bottom circle. And since the radius of the cylinder is r, the area of the top circle and the bottom circle is going to be pi r square each. So the total surface area of the cylinder is the curved surface area, which is 2 pi r h, which we have obtained here, plus the area of the base circle, which is pi r square, plus the area of the top circle, which is also pi r square. So we get 2 pi r h plus pi r square is 2 pi r squared. Then we take the common factors out, which is 2 pi r, and we get 2 pi r into h plus r. So that's the formula for the total surface area of a cylinder. So basically the total surface area of a cylinder is equal to the curved surface area plus the area of the base circle, which is this circle, bottom circle, plus the area of the top circle, which is the top part over here. Okay, so now we have just recall what is the meaning of surface area, and also recall what are the formulae for calculating the surface areas of certain bodies or shapes, three-dimensional shapes that we have studied in earlier classes. Now let's move on to some new shapes which we will study in this particular session. So in this session we are going to talk about the surface areas of a right circular cone and also the surface area of a sphere and a hemisphere. Okay, a cone is a shape that you are all familiar with. When you have taken an ice cream on a cone, that the shape that you get is basically a conical shape. Okay, so the cone is basically formed by or can be formed by rotating a right angle triangle along the height, and it forms a three-dimensional object called as the cone. Okay, a conical shape is formed. Okay, so the point A is called the vertex of the cone, and then at the base of the cone is circular in shape. So the cone will have the radius of r at the base of the cone, and it has a certain height which is from the center of the base to the vertex of the cone, and then there's a slant edge which we call as the slant height of the cone. So we have a height h and a slant height L of the cone, and the angle between the radius and the height of the cone is 90 degrees. So that's why we call it as a right circular cone. So the dimensions of interest for us are the radius of the base, the height of the cone, and the slant height of the cone, which we denoted as L. So the radius is denoted as R, the height is denoted as H, and the slant height is denoted as L. And the curved surface area of the cone is basically the area on the outer surface of the entire cone. So if you're holding an ice cream cone in your hand, the curved surface area is basically the area on the entire exterior part of the cone, and that is given by the formula pi r L. So pi is the constant that we are familiar with, 22/7. R is the radius of the base of the cone, and L is the slant height of the cone. So the curved surface area is given by this formula pi r L. Now sometimes we may be given the values of h and r, and we'll have to compute L before we compute the curved surface area. And since we know that the radius r and the height h are at right angles to each other, therefore this ABC forms a right angle triangle, and we can apply Pythagoras theorem to calculate the slant height L using the Pythagoras theorem. So we get the slant height L as square root of r square plus the h square. Okay, so in some example problems we may not be given the slant height directly. We may be given the height of the cone and the radius of the cone, and we'll have to compute the slant height of the cone using Pythagoras theorem according to this formula here, and then we have to substitute that value of L in the curved surface area of the cone using the formula pi r L. Now the other surface area for the cone is the total surface area. The total surface area is nothing but the curved surface area plus the area of the base circle. So if we include the base circle of the cone, which is circular in shape, so the total surface area will be the curved surface area of the entire cone plus the area of the base circle. So we have the curved surface area given by pi r L, and the area of the base circle is going to be pi r square, because the area of the circle formula is pi r square and we have the radius as r. So we can take the common factors out and we get pi r into L plus r. So that's the formula for the total surface area of the cone, which is nothing but the sum of the curved surface area and the area of the base circle. So we calculate the curved surface area and add the area of the base circle. That gives us the total surface area of the cone. Let us now look at the next three-dimensional geometric shape that we are going to calculate the surface area of, and that is a sphere. A sphere is basically like a ball, okay, a normal football or a yoga ball that we use. It's a three-dimensional shape with a certain radius r. It has a circular shape but of 3 dimensions. So the radius of the sphere is given to be r. And for a sphere of radius r, what is the surface area? The surface area of the sphere is given by the formula 4 times pi r square, where r is the radius of the sphere. But if you remember that the area of a circle is given by pi r square, so the surface area of a sphere is 4 times pi r square. That means the surface area of a sphere of a certain radius r is equal to 4 times the area of a circle of the same radius r. So we have the surface area of a sphere as 4 times the area of a circle of radius r, which is 4 times pi r square, which is what we have in our formula. Okay, so it's a fairly straightforward formula for calculating the surface area of a sphere. Again, it's basically like computing the total area on the surface of the ball. Okay, the sphere is the shape of a ball, and if you want to calculate the total area on the outer surface of the ball, that is what is called as the surface area of the sphere. And we see that the surface area of a sphere is 4 times the area of a circle of the same radius. Okay, now let us look at the next shape, which is a hemisphere. A hemisphere is basically obtained when we cut a sphere into 2 equal parts by slicing it exactly along its diameter. So when we slice the sphere exactly along the diameter, we get 2 hemispheres, and we are interested in calculating the surface area of the hemisphere. Again, we will have 2 types of surface areas here, which is the curved surface area and the total surface area. In the sphere, however, the only surface area available is the total surface area, which is exactly equal to the curved surface area. So for a sphere, the curved surface area and the total surface area both mean the same thing, because there is no flat part on a sphere. However, in a hemisphere, when we cut the sphere into 2 equal parts and get hemispheres, each hemisphere has one flat side. So this part, which is shown in dark green here, that is the flat part, and the other side is having a rounded shape, which is basically like in the shape of a ball. So that rounded shape has a certain area. So the surface area of a sphere has 2 components. The first is the curved surface area, which is the area of the curved part or the rounded ball-shaped part, and then we have the area of the flat part, which is a circular shape. So we can calculate only the curved surface area or the total surface area. So the total surface area will be the curved surface area plus the area of the flat part, which is a circular shape. Okay, so the curved surface area of a hemisphere, as we can understand, is it's going to be exactly half of the surface area of a sphere, because a hemisphere is exactly half of a sphere geometrically, right? So the curved surface area of a hemisphere is half the surface area of a sphere. So it's half into 4 pi r square. 4 pi r square, as we have seen earlier, is the surface area of a sphere. So therefore, we get the curved surface area of a hemisphere as 2 pi r square. So the curved surface area is basically the area in the curved part where we have like a ball shape, a rounded ball shape. So this area here is the curved surface area of the hemisphere, okay, of this particular hemisphere over here. Similarly, for the hemisphere on the left side, the curved surface area will be this area over here, okay. Next, we can calculate the total surface area, which will be the curved surface area plus the area of the flat side. So the total surface area is the curved surface area, which is 2 pi r square, plus the area of the flat side. The area of the flat side is this part over here. So we have this part, the area of the flat side. And the curved surface area, as we have seen before, is this part over here. So this is the curved surface area, which I have shaded in black, and the area of the flat side is shaded in red lines here. So now the total surface area is the sum of the curved surface area and the area of the flat side. And because the flat side has a circular shape, the area of the flat side is pi r square. So the total surface area of the hemisphere is the curved surface area 2 pi r square plus the area of the flat circular side, which is pi r square. So we get the total surface area of a hemisphere as 3 pi r square. So now we have all the information, and we are equipped with all the formulae to calculate the surface areas of the various shapes of interest for this particular course. And in the next video, we will be doing some examples of calculating surface areas of these various shapes, and see how we can compute the surface areas, and we will see in what case we compute the curved surface area, in which situation we compute the total surface area, and so on. Okay, we'll continue that in the next lecture.